How many of these molecules are polar? SO3, OF2, BeCl2, CCl4, and O3. The first thing that we're going to do for each molecule is draw the Lewis structure, then identify bond dipoles using differences in electronegativities, and then we're going to identify net molecular dipoles based on molecular geometries. For the first molecule, SO3, in order to draw the Lewis structure, we need to figure out the valence electrons that we have. S has 6, O has 6, and there's 3 O's, so we need to times 3 by 6. So 6 plus 3 times 6 is 24 valence electrons that we will have for this Lewis structure. So now we're going to start building our Lewis structure. An S with 3 O's attached. Now 2, 4, 6, we have used 6 electrons so far. So now we have 18 left to put around. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now if you notice, S does not have 8 electrons around it, which means we need to make a double bond somewhere. But when we do that, we see that this Lewis structure is a resonance structure because they can have one double bond by any O and 2 single bonds by any O. So I'll just draw one of the structures right here. And now we can figure out the partial charges. In order to do that, we have to look at the electronegativities. O has a bigger electronegativity than S, which means it's going to have the partial negative. So all the O's will draw partial negative by them. And the S will have the partial positive. In order to draw the bond dipoles, we start at the partial positive and go to the negative. So this bond dipole will go this way, this one will go this way, and this one will go upwards. The direction of the bond dipole is the direction of charge separation, and the length of the arrow represents the magnitude of the charge separation. Now, we're going to look at our domain geometry. We have 1, 2, 3 domains, which means it's a trigonal planar. We don't have any non-bonding pairs, so its molecular geometry is also a trigonal planar. Now we're going to redraw the structure down here with the dipoles. In this structure, the dipoles cancel and there is no net dipole. The dipoles cancel because for electron domain geometry, all 3 domains are the same. So that means SO3 is nonpolar. Now on to the second molecule, OF2. We figure out the valence electrons we have, which is 20. We write our Lewis structure. Then we find out the partial charges. For this one, F has a bigger electronegativity, which means it's going to have the partial negative, and O is going to have the partial positive. So the bond dipoles are going to go from the partial positive to the negative, and the partial positive to the negative. And if we count the domains, 1, 2, 3, 4, it's a tetrahedral. But it has 2 non-bonding pairs and 2 bonding pairs, which means its molecular geometry is bent. So we draw it right here with its 2 non-bonding pairs and 2 bonding pairs. And it turns out that you have to add the dipoles in order to get the net dipole, which will be down. The dipoles don't cancel because all 4 domains are not the same. There's 2 bonding and 2 non-bonding. So OF2 is polar. Now, the third molecule, BeCl2. We need to find its valence electrons in order to draw the Lewis structure, which is 16. So we come over here and start drawing the Lewis structure with the 16 valence electrons. Once we do that, we notice that Be can violate the octet rule, so it is okay that it does not have 8. Next, we need to find the partial charges. So we know that Cl has a bigger electronegativity, which means it's going to have the partial negative, and Be is going to have the partial positive. So the dipole is going to go from Be to Cl and Be to Cl. We're going to count the domains, 1, 2, so its domain geometry is linear, and since it also does not have any non-bonding pairs, the molecular geometry is also linear. So we're going to come over here and draw it. The dipoles cancel, so there's no net dipole, and the dipoles cancel because the two domains are the same. So BeCl2 is nonpolar. For the fourth molecule, CCl4, we have to figure out the valence electrons, which is 32. Now we know we'll have 32 electrons in the Lewis structure. So we draw the Lewis structure, make sure they have 32. Next, we look for the partial charges. So we have to see if C or Cl has a bigger electronegativity, and Cl does. So it has the partial negative on every Cl, and C has the partial positive. So we draw dipoles from the positive to the partial negative for every C and Cl. So then we count our domains, 1, 2, 3, 4. So it's a tetrahedral. The molecular geometry is also the same. That's a tetrahedral. So we come over here and draw it with our dipoles, and the dipoles cancel, so there's no net dipole. The dipoles cancel because all 4 domains are the same. So CCl4 is nonpolar. For the fifth molecule, O3, we need to figure out the valence electrons, which is 18 for the whole Lewis structure. This Lewis structure also has a resonance when one O can have a double bond and the other one can have a single bond. So we'll come down here and draw that, just one of the resonance, and we'll make sure that every O has 8 electrons. So then we count the domains, 1, 2, 3. So its domain is a trigonal planar, and since it has a non-bonding pair, its molecular geometry is bent. Since this is O3 and all the atoms are O's, they all have the same electronegativity. Since all the domains are not the same on the central atom, there is a net molecular dipole. So this O3 molecule is polar. Out of the 5 molecules we had, OF2 and O3 are polar. The common mistakes when drawing Lewis structures are that H, He, Li, Be, and B can have less than 8 electrons. Also, the third row and below on the periodic table can have more than 8 electrons. Be careful when counting domains because it is easy to mess up.